Okay, it's time for us to work on our third weekly essential. We're doing these weekly essential lessons as a review of things that we have previously covered in coordinate algebra to get ready for our end of course test in May. This lesson is on solving different kinds of linear equations. Remember, ultimately our final goal is to isolate the variable, so in the end we'll have a statement similar to x equals a number, and that number will be the thing that we could place in the place of x to make it true. That is a little bit different when we've got more than one variable, but we'll look at those in a minute. Okay, so ultimately the three basic steps in solving any linear equation, first is to check each individual side and see if any simplifying can be done. We want to make sure each side is simplified. Then we want to collect any variables. If there's variables on both sides of the equal sign, we want to collect all of those on one side. And then finally, once we have all the variables on one side, then we're going to do our inverse operations to isolate that variable. So it'll be by itself and we'll get that statement that we want. So for instance, in number 1 here, we've got some simplifying that we can do on the left. First of all, we can get rid of these parentheses by using the distributive property. Each term multiplied by 4. 4 times 2x is 8x. 4 times minus 3 is minus 12. Okay, copy down the rest of it because we haven't worked with it yet. Still a little bit more simplifying that we can do. There's a minus 12 and a minus 2 that are like terms. I can combine those and get 8x minus 14 equals x. Okay, at this point we recognize that we have x's on both sides, so we need to collect them on one side. Okay, I am going to subtract the 8x. It is okay to subtract the x from both sides, but I tend to not subtract the x when that's the only thing that's over there. So on the left, I have 0 minus 14, which is negative 14. On the right, I have negative 7x. So I'm finally ready to isolate the variable x. It is multiplied by negative 7, so I'm going to divide by negative 7 on both sides using the division property of equality and get that x equals 2. And that is the number that I should be able to plug in the place of x that would make the original statement true. Okay, next up, all right, a couple different things about this one. So you'll kind of get a little confused when they see a fraction. If one side is one big fraction, if everything on this side is divided by the denominator 3, then we can always get rid of that by multiplying both sides by 3 first. Because what's going to happen is those 3's are going to reduce, and then we'll just have 2x minus 1 over here, and then equals negative 15. I jumped ahead of myself just a little bit. I checked to see if there was anything that could be simplified. I didn't need to collect variables because that variable x was only on one side, so I went ahead and started isolating the variable. Okay? All right, so now we're going to use our inverse operations. We're going to get rid of minus 1 by adding 1. And then I'm going to divide both sides by 2 to get rid of times 2. And get x equals negative 7. Okay, number 3, this time we have more than one variable and we're told to solve for y. So even though there is the other variable x in there, I'm going to pretend like that 3x is really just a number because we know x is holding the place of a number, and whatever that number is being multiplied by 3, so that just gives us a new number. So I'm going to treat y as if it is the only variable in this problem, and I'm going to work towards isolating it as if everything else in the problem was a number. Okay? All right, so I'm going to subtract the 3x from both sides, and I'll get negative 4y equals. Now I've got a couple of options here. I can just write 20 minus 3x as is. Okay, but what we tend to do, because a lot of times when we're solving for y, we're trying to get it in slope-intercept form for the purpose of graphing. So we tend to write the variable term first, negative 3x and plus 20. Okay, now I'm going to finish isolating y by dividing by negative 4. I'm going to divide the whole right side by negative 4, but the easiest way to do that is just divide each term by negative 4. Okay, these will reduce, and I'll have y equals a negative over a negative will give me a positive. Okay, I'm going to break the variable x out, so I'll have a coefficient 3/4 times x, and then I'm going to simplify 20 divided by negative 4 and get negative 5. So my final expression for y, my final slope-intercept equation, is y equals 3/4 x minus 5. Okay, number 4. Okay, got some simplifying I can do. Okay, you may have noticed there's more than one variable again, but I still have got to simplify both sides. Distribute the 6 on the left will give me 6x plus 24. Distribute the 2 on the right will give me 2y plus 10. Okay? All right, I'm solving for the variable y again, so I want y by itself. So I'm going to subtract this 10 over. Get rid of plus 10 by subtracting 10 using the subtraction property of equality. So I'll have 6x plus 14 equals 2y. And then finally, to get y by itself, I'm going to divide by 2. And again, the easiest way to divide one side by 2 when there's more than one term is just to divide each term by 2. So I'll have y equals 6x divided by 2 is 3x, 14 divided by 2 is 7. So I have solved for y because I have isolated y on one side by itself. All right, next up, we're not only going to solve this equation, but we're also going to justify each step as we go. Okay? The justification for the first step is always g for given. Okay, just like before, I want to go through the process of simplifying both sides first. So if I distribute the 3, I'll get 3x minus 3 equals 5x plus 1. And the justification for that is the distributive property of equality. So I'm going to put letter D from over here in the chart. Okay, both sides are as simple as they can get, but I need to collect the variables on one side. So I'm going to subtract 3x from both sides. So I'll have negative 3 equals 2x plus 1. And I'm going to justify that by the subtraction property of equality because I got that by subtracting 3x from both sides. Okay, next up I'm going to subtract 1 from both sides. So negative 4 equals 2x. Again, I use the subtraction property of equality. And then finally I'm going to divide both sides by 2. So my final solution is negative 2 equals x, and I can justify that by the division property of equality, and I just realized I used the wrong letter for distributive. Let's fix that. Okay, we had to use F for distributive property, not to be confused with D for division property of equality. All right, finally, number 6. Okay, we're going to solve this formula for the variable h. Now, one thing I would like to do first is get rid of that fraction again. So just like I did on problem number 2, I'm going to multiply both sides by 3. Those will reduce, and I'll have 3v equals pi r squared h. Now at this point, everything on this side is being multiplied by h, so I get rid of multiplication by dividing. So I'm going to divide both sides by pi r squared, and I'll reduce every bit of that. And my final equation for h will be 3v divided by pi r squared. Okay, you'll have a quiz over these weekly essentials in about a week.